Hello and welcome everyone. My name is Zubair Altaf Qureshi and welcome to my channel Z Network Lessons. And in this video, we will be continuing the topic of NAT on the Cisco ASA. In my last video, we did the dynamic NAT. So as of now, you know that NAT is used to translate the IP addresses, mostly private to public. Right? Now, the one that we saw was dynamic, and we created a pool of public addresses and all our internal devices with the private IP address used to take one IP address from the public pool and go to the internet, and then the next one from the internal private pool will take the next address, and it will be a dynamic allotment, right? So now the next thing that I want to tell you is about the static NAT, what it is and why we use it. So mostly the static NAT is used to translate a single real address to a single mapped address, means a public address. This is, you can say, one-to-one translations. Okay, and I mean that address should be routable on the destination network. For example, if I want to reach from my internal PC, okay, I have a PC here internal, and there's an ASA here. So let's think this is an ASA, and I have to reach some server on the cloud, which has a public IP. In this case, let's say this is the Google IP of 88888. This is DNS server. So I want to reach this DNS server. Right? So this DNS server should have that IP address that is going to be translated. I mean, the public IP that should be routable here. So if I am going to translate this internal IP of 10.1.1.1, and I would translate this to say 20.1.3.2, which is a public IP, right? This is a public IP, this is a private IP, and the IP that I'm going to translate this to should be routable on this device. That means that should be routable on the internet in this case. Okay, because this is a public IP and this server should have a default route or something that should be pointing, and somehow it should be reachable to this IP because of the public nature, right? And the most important thing is that the static NAT is bidirectional. The one we did, the last video was dynamic, and it was only one way, that is called the unidirectional. Even the static PAT is unidirectional. So what that means is, so for example, I had let me just clear this drawing and let me start with the new one. So for example, in the dynamic NAT, I had a PC inside which wanted to reach the internet. So this is my firewall like this, for example, and it has a connection to the internet, and somewhere in the internet I have a Google DNS server which my internal PC wants to reach. So for example, what happens is this has been initiated by my internal resource, like this packet. So I have a DNS request that has been created by my server. So once it goes outside, there is a dynamic NAT pool here, and it gets an IP from this pool, say 20 dot something, and in our case, and it reaches the 888, and it replies back to this guy. And that's how the untranslation happens, and the internal user gets the return traffic. Now imagine if this server initiates the packet to this IP, it will not be untranslated. So that is what is called the bidirectional and unidirectional. So this case is what? Unidirectional. So that's why I said the dynamic NATing is unidirectional, while as static NAT is bidirectional. So mostly you will see this configured when we have a server in the DMZ. Okay, this is my DMZ, So we will be demonstrating it on DMZ3 servers. So in our case, we have a router, and I will try to enable Telnet or an HTTP or something, and I will show you how this works. Okay, so for example, we have a web server which is serving some HTTP requests. So this guy on the internet doesn't know the, he cannot reach the private IP address of this uh, router, right? Or this server. So how it, reaches the, how it is able to access the servers that these servers are, serving on the DMZ is with the help of static NAT. So what we do is we bind this private IP to a public IP on the internet, which we have, taken from the ISP, and we actually create a DNS record for that IP. This is called the A record. So we have a record on our DNS server which says the translation from the domain name to the IP address, to the public IP address. Okay. So for example, we register that IP address with the domain name of www.zbnetworks.com, right? And once the DNS request is received and this A record is read, then the ZB networks gets translated into 192.1.20.11. Okay, and now the public server has this IP, and it goes to that IP, and once it is hit on this ASA on the outside interface, it checks the translation table, and it checks the rules as well, if it's allowed or not. In this case, it should be allowed because it's from the low to high, so there we should have a rule there. While as internal high to low, you don't need that rule, right? Because TCP and UDP is inspected. So those are the basics. So let's move on to the NATing part. Once you have the rules and you have the NAT, the translation will happen, and the destination will be actually changed from 11 to 3.3. 192.168.3.3. You will see the same concept in other firewalls, and where that they call this as the destination NAT. But in case of ASA, specific to ASA, this is still a source NAT. Okay, don't get confused on this. This is with respect to only ASA, because 99% on ASA is called source NAT. Okay, because with respect to ASA, it's like when your address gets translated, it's called what? Source NAT. And when the remote address is translated, it's called DNAT, destination NAT. In this case, what we are doing, source NAT, right? Even it's in the destination field of the packet. When the initiator from the outside hits this IP on the 20.11, and we translate the destination IP to 3.3, but this is my address, right? This belongs to me, 20.11 or 3.3, right? While as 8.8.8, which is the source on this packet, doesn't belong to me. If I change that 8.8.8, that is DNAT for ASA, and we will see that in the future videos, right? So how do we do this? Let's do some of the examples so that you understand this. But before that, let me just I covered that this is bidirectional, and static PAT and your dynamic NAT is unidirectional. And some of the examples you can see here, how you configure the static NAT. This is one of the ways you configure static NAT. I'll show another one as well. So in this case, we will be using the objects, right? So you will create two objects. You have the real object, which will be your private IP address, and then you will have the public IP address, which is called the map. And how you do it is you say the NAT, and inside, and then the outside, and source, and here static. So in that dynamic, you had the dynamic keyword here. Then you say the private address and then the public address. So there is another thing that you need to understand about this NAT, NAT statement, right? So when you create an object, right? So when you create an object, and when you name that as network, say inside, okay, and then you say, right, the host or the subnet, whatever you need, and then you say the IP address, and then you say the NAT statement, and then the inside outside whatever. So this is basically always the high one, sorry, the high address, and this is the low security level address, and this is always and always the high security level address. Understand? But in this case, you can see this is my what? I have configured this as my high. I mean the low, right? The public. But I mean, just ignore this because I am telling it not based on this one. I am telling it based on the examples that we will do. This is one type. Just remember that this is the high address. Okay, and then you have the here you always say the low address after the static or the dynamic. You always say the low address. Okay, and now this high is always linked to this, and this low is always linked to this. Okay, so this is 99%. This will be like this, and I will show you when this would change. So always high, low, and here you will, after the static or the dynamic address, always the low address, the public address here, okay, on which you want to translate it to. So that is one thing that I wanted to, clear the concept to you guys. And now what I want to show you is some of the topics related to the static NAT. Right? And once you create the static NAT, right? So let me just close this. Okay. So when you create a static NAT, what happens is the entry is created the time you enter the NAT statement, because this is a what? This is a static NAT, and in the dynamic NAT, you wait for the traffic to be initiated, and then only you see the NAT translation. But here, when you enter that before the traffic hits the ASA or the public IP, the NAT translation will be there in the table. We see that. Okay, and as I said, static NAT is generally used to translate the public-facing servers on the DMs. Okay, the reason for that is the clients from the internet will need a fixed IP address to send the request. Right, you need a public IP address for the clients, and you need the ACL needs to be configured for the out to in traffic, or you can say the low to high traffic. So there needs to be, on top of creating an NAT statement, you have to have the ACL configured. Okay, and remember this, that the ASA beginning from 8.3 and above, the ASA translates first and then checks the ACL. So that means always you will have the private IP address in the ACL. Simple as that. Just remember this. Prior to 8.3, it was different, but you don't need to understand that. So anyways, so this is what we have. Okay, so let's go to my topology. I think I have it here somewhere. Let's bring a new tab. I have my server 192.168.1.99. Let me just log into my server. Great. Let me turn on my EVNG virtual machine, this one, and we will start with the topology. And we'll see how we can do the translations and how we can verify those translations have been configured. Right? So we turn on this. Should be okay for the time being. I'll pause the video and again I will continue once the servers up. Okay. Okay, so I have the topology here. So this is what we are going to do. Let me just get my pen and start drawing. So what my plan is that on R3 here, what we will do is we will enable Telnet, or say we will allow ICMP. So whenever a person from the outside, which is our R2, this guy, if he reaches on 192.1.20. Say 50, it should, this AC should translate it to say 10.3.3.1, and we should have a ping only for ping. If somebody pings on this address, then it should translate and go to 10.3.3.1. Okay, and you will create an access list here also. And also what I'll do is, if a person comes to 20.50, say 52 or 53, whatever, let's see when I do the translation. So what should happen is this should be translated to here dot 3 on this interface. Okay, and this should be only done when we have a telnet packet. Okay, so I will configure this as the I will allow a telnet here in the ACL. Okay, so that is what. And also just to let you guys know that we will also create two NATing and two ACLs for web traffic, which should be your port 80 for HTTP and port 443 for HTTPS. And I'll also show you the translation for that and also the access list, but I'll not be able to demonstrate because we don't have that. But I'll be testing with the Telnet and the ICMP packets, right? So yeah, that's the plan, and let's see what we will do. So I'll clear this and let me take my notepad, which I have here, this one, and what we will do is we will have the the translations. Okay, so let's see the plan of implementation like that. Okay, what we want to do is we want to have a 192.168.3.3, which is our which is the R3, right? It should be translated to 192.1.20.53, and that should be for your say telnet. And the same thing 10.3.3.1, if it should be translated to 192.1.20.52, and it should be allowed on ICMP like that. And also for your web, right, we need only what 192.168, say 1.11, not 1, 3.11. This should be translated to 192.1.20.50, and this should be your web server, right? Web server, we should have the 80, port 80 and 443. And also on the ICMP, you don't need anything. This is ICMP, and telnet should be 23. You will specify telnet as well, yes. And then also you need the ACLs. So ACLs, configure the ACLs. So ACLs, how it should be. So before ACLs, that configure the NAT statement. As I said, the syntax. Okay, syntax would be like you should have the object, and then network you will specify, and then the name of the object. Okay, so as for the service of web, you would say web, or maybe something like that. ICMP, Telnet, depends on you. So then you say the host and the high address. I mean, this is your high level. This high security level, which will be your mostly the private address. And then the NAT statement would be like this: high and comma low. I mean, this is the security level, and then you say static, and then you say the IP address of the low security level, which will be your public IP address, the outside. Yeah. So this is the syntax. Okay, and always remember this. Wait a second. As I said earlier, that this will always be with this one, and this will always be with this one. So remember that. Clear this. You also have the option to configure the objects. So how do you do that? As I have specified in my here. So you create the object. This is the pad. This is the static pad. Okay, here have the static NAT. So you have the object network, the real object, which is your private. Then you say the mapped object, which is your public. Then you say NAT, high, low, and then source. You specify the source keyword, and then static, and then the again the this is like the the high and the low. So high comes here and the low comes there. Okay, so like that. So we can do it like this also. This is like from the global. This is called the globe. Creating NAT on the global. Uh, I mean, uh, configuration. While we do the other one, which you will see in the examples. We do it in the object. Okay, and this has a difference in a sense. If you do it globally, it will go in the section 1. So this is also important, and I would like to go and throw some light on this. So if you do something like this, there are actually sections. I will show you in that. You have section 1, you have section 2, you have section 3. So and section 3 in the NAT table. Okay, so it actually has a preference level. So section 1 has a higher preference than section 2, and section 2 has a higher preference than section 3. Now, what is this section and all these sections, right? So if somebody does a global NAT, it goes in section 1. That means global NAT will be preferred over section 2, which is the dynamic NAT, which you do on the inside the object. Okay, so if you do any NAT inside the object, that goes into section 2, and section 3 we will talk about this later. So as of now, just understand that the section 1 is the NAT that you do on the global configuration, and when you do the NAT inside an object, it will be in section 2. Okay, so that was a brief info on that. I'll clear this. Okay, now let's do the configuration on my ACs. So I have my AC here. Let's go to the putty. Okay, let's see the ASA. So do I have any NAT configuration? No. Show interface IP brief. Yeah, so I have my IP address. I can ping my 192.168.3.3 is my router. I can ping them. Can I ping show route? Let me see the route if I have to my 10.3.3. I don't think I have a route, so I need to check on the R3 that I have that. For the ping, right? Show IP interface brief. Yeah, I have 3.3. Show IP route. If I see, I have a static route towards the ASA, but ASA doesn't has any route, so I should have a route towards DMZ3 and address is 3.1.0.0.0, and then you have the next hop, that is 192.168.3.3. So that, okay, the mask is not right, so this should be okay, done. So now if I try to ping this 10.3.3.1 should be reachable. Yeah, so my AC can reach the loop back on R3 because I'll be translating this loop back to some address on the public side. And then on R2, I have enabled this one, and I can ping 192.1.20.10. Hope you remember all the IP address schemas. So R1 I don't require as of now because we'll be working with R2 and R3. So let's start with the what? With the So let me just open this. Okay, so I need 3.3 to be translated to 1.20.53 and Telnet. Okay, let's do the natting first. So for this, I need what? I need on ASA. So 3.3 is my router, and it should be translated to this IP. So object, and that too should be Telnet. Let's say object network. So let's name it Telnet. Telnet to R3. Telnet R3, right? And then I have to specify the high address. So I will say host, and this is my high interface 3.3, and then I have the NAT statement. Now NAT is from the high interface, which is my DMZ3, to my outside, right? Outside. Oh, okay. So this should be like outside, comma, and then I can have the static, and then your low address again. Okay, so this is my address that I want to represent on the outside. So this is a one-to-one NAT. So whenever a person comes on 50.53 on the outside, it will be translated to 3.3. Okay, that and we will specify this only for the ACL. We will have to specify the traffic type. Okay, and then we have the so I'll exit from this. And this should go into section 2, right? And let's go to the next one, which is my object and the network, and I will say ping. This is my ping, and I will say host. This is my 10.3.3.1, and this will be NAT. My again DMZ3, comma outside, right? And then again say static. And then the IP address that I need is 192.1.20.52. Done. I will again exit, and I need next one for my web. So again object, then network, say web. Okay, and then I have the host, which is 192.168.3.11. I don't have any host, but this is just an example. And I will say the NAT statement again from my DMZ3 to my outside, and then static, and then the IP address that I need. That is done. Now exit. Now I need the access list. Now access list, which I say out permit. Now I need the telnet TCP any, that can be any from outside, to host. Now the IP address should be what? It should be the private. Okay, this is for the telnet, and I'll be doing the telnet to the R3, and then we can specify the telnet like this. You can say telnet, or you can say port number 23 like that. This will also do. Okay, then I have the next statement, access list, same out permit. Now I need for the ICMP from any to my host, which one? 10.3.3.1. Here also you can see echo reply, whatever you want. And then you have the access list for out permit TCP any to host 192.168.3.11 EQ. You can have one for HTTP and one for the HTTPS. Okay, so we have the NAT statements, right? Now this is, because this is a static NAT, so when I say show xlate, there should be translations in the table because this is static. So you can see as from DMZ inside, from the high security level, you have 10.3.3.1, which is represented on the outside as 52, and this is actually for the ICMP, right? The ping. and also from the DMZ, the dot 3, which is the router itself, is represented 53. So we have to telnet at 53 and ping to 52 to get the reply, right? And that's it. So let's go on to the and also you can see show NAT detail, as I wanted to show you one thing. So you can see this is in section 2, right? Okay, because this is not the I mean, we did it inside the object, we didn't do it globally, so that's why it is in section 2. But if we do it globally, then of course it will be in section 1, and section 1 is always preferred than section 2. And inside all the sections you have the I mean the what do you say, it's like top down order wise, it will be index wise, index number. So first one will be checked first, then second, and like that. Okay, so let's go to R2, and as I can see in my here 10.3, so I need to ping on 52. Okay, so if I do here, it should be from R2 52. Okay, I need to ping 192.1.20.52, and this should be translated to and I need to see if I have the, okay, I have not applied the access list, right? Yeah, so I need to apply access group out in interface outside. Okay, now it's fine. I'll go to R2 again, do the same thing, and this should be translated and the ping should be successful. You can see. So how do you check it? So you say show NAT, or you can say show NAT also. Yeah, show NAT. If you see, you will see the hits. So you can see on that ping you have a hit of untranslation. Okay, so untranslation is the number of packets you send from here. So that many times it will be translated, right? So if you again do this, let's see, and hit is 1. This is the actual translations, untranslations. Okay, so this is flow wise, and this is packet wise. So now the problem is how to check on R3, right? Because let's do a debug, because you need to see what packet you are receiving and from what IP address you are receiving. And yeah, so or what you can do is we can do a packet capture. That would be more on gig 02. Okay, and I will capture gig 02 here, and you will see the packet that is arriving and leaving this interface. So I mean, by default what it should be is so it should be like so when the packet is created on R2, source and destination. So my source should be the R2's address. I think it's 192.1.20.2. This interface, G00 interface. This should be the source. And destination, as I said, I am doing 192.1.20.52 for the ping, right? So this is the one. Once it hits the ASA and then the untranslation happens, the source should be the same and the destination should change. The source should be 192.1.20.2 and the destination now should be translated to this one. Okay, so let's see if this is the case on the capture that we are doing. So let me go to my Wireshark. Okay, here I have the Wireshark. So let's generate a ping from R2 from the outside. The same ping we did earlier. We should have some packet here. Yeah. Now let's grab this one, and you can see on the source you have 22.2, and then the destination has been translated to, because I did a ping to 52 right here in my, here you can see what I'm pinging, 52, but it has been changed to 3.3. Yeah, and the reverse should be also possible because of the translation. So if I go to R3 and ping the which one, 192.1.20.2, 2, I think. Yeah. So that is the address on the, but I have to do it with the source. You know why? Because I am translating the source. So if I do source, then I say loopback, source loopback 0, right? So this is my which one? Yeah. So I can do this. So this is what I say is, now if you check this one, it should be the 1033 should be translated to that will be seen where? That will be seen on the R2. So if I go to R2, this is what is bidirectional. So if I say debug IP packet details here and do the same ping from R3 with the source of loopback 0 and go to R2, and you will see that you will receive packets from 52. Let me just do a U all. Yeah. So you will see that you have received this is the reply that is going, but the source of this packet should be here. See, 52. So that is how what I mean by the bidirectional, right? And that was the ping, right? So from R3 we did another translation, which is the Telnet. So for that I need to see if on R3 I have Telnet enabled. So run section VTY. Should have something here. Yeah, I have Cisco 1 transport. Okay, I have this. So on R2, I should Telnet on what IP address? 53. So let's Telnet 192.1.20. This should land me up on R3. Yeah. So Cisco 123, and if I see, I'm on R3, right? And I can say show users, but this will be the IP address of my R2 only. With the source, I'm not changing it. And the likewise I can do. I can go to R3 and go directly to Telnet 2, provided that Telnet is enabled on my 2, like this. Yeah, it is enabled. So Cisco 123. This is because of the bidirectional nature of the static. So if I see now, it should be .53 here. 92.1.20.53 will be the source. Now the source will be translated, right? So you can see here, yeah, 53. So that is how it is, right? And if I did something wrong, I should say exit, and Control Shift 6X should work, yeah, and I should say exit. So I should be on R3. I was actually on R3 already. So that is the two types of the NAT verifications we did. One was the ICMP, second was the Telnet. So web I cannot do, but that is how it is. Okay, so hope you understood all these statements. But what you need to do is you need to go through all of it again and practice, and you will understand once you practice these concepts with your own, creating your own lab and try to go through all this again and again. Okay, so that would be it for this video, everybody. See you in my next video. We will be continuing the NAT part because we have a lot to cover. We just did the dynamic NAT and the static NAT. Now we have the dynamic PAT, static PAT, policy NAT. Yeah, so we will cover that in the future videos. Until then, bye bye. Take care.